Okay, so in this video we're going to learn how to balance a redox reaction in acid. So as we can see right here, we have a reaction where aluminum solid and permanganate goes to aluminum 3 plus and manganese 2 plus. So you can see right here the steps that we're going to have to follow. So the first thing is we have to divide into half reactions. Then we're going to have to balance each half reaction. And the way you do that is you deal with the elements besides hydrogen and oxygen first, then you do oxygen by adding water. Going to add the hydrogen by an H+, balance the charge by adding the electrons at the end of all that, and then multiply the two by some integer number, usually the other one balanced, in order to balance the electrons, so when you add them out, you can cancel it out. So let's go ahead and do that. Okay, so the first thing we're going to do is split into the half reactions. So we have two here. The first one's going to be aluminum solid going to aluminum 3 plus. Okay, if we were to do oxidation numbers and look at this, the aluminum solid has an oxidation number of 0, 3 plus has an oxidation number of +3. So this is my oxidation reaction, and therefore we would consider aluminum to be the reducing agent. And if we look at the other reaction, we have the permanganate going to manganese ion here, and in this case we're going from the manganese and the permanganate having a +7 to a +2 in the manganese ion, and therefore it is being reduced and is the oxidizing agent. So for the aluminum, okay, pretty simple. The aluminum is balanced. There's no O's or H's to worry about. We just need to add the electrons in. So +3 electrons. This half reaction is all set. For the permanganate, it gets a little more complicated. So the first step we're going to do is we're going to balance out the oxygens with water. So that's going to require 4 H2O on this side in order to balance out the 4 oxygens from the permanganate. The second thing we're going to have to do is now balance the hydrogens by adding H+. Since we're doing this in acid, H+ is readily available, so we need 8 of those because we added 4 H2O, sorry. So 8 hydrogens to the right, we need 8 on the left. And now last up is going to be we have to balance the electrons. So if we look right now, we have a charge of 2 plus on the right, we have a charge of 7 plus on the left. In order to bring that into line, we need 5 electrons on the left. If we take a quick look at the oxidation numbers, we've said that the aluminum was the oxidation reaction, and that makes sense because we have our electrons balanced on the right. The permanganate underwent the reduction, and you can see that since it's gaining electrons, they're on the reactant side, so we have those written properly. So now I'm going to just multiply the first reaction by 5 and the bottom permanganate reaction by 3, and what that will give me is 15 electrons being lost on the top reaction, 15 electrons being gained in the bottom reaction, and therefore they're going to cancel out when I put this all together. So putting it all together, simply are going to have 5 aluminum solid plus 3 permanganate plus 24 hydrogen ions, H+, plus 15 electrons, which will cancel out in a second, going to 5 aluminum 3 plus 15 electrons plus 3 Mn2 plus 12 water. And you can see that the 15 electrons on the left that were used up were released by the other one. Those cancel out, and that's what we're left with.